Hello guys. So I wanted to go over this video specifically to go over some of the most common algebra mistakes that students make constantly. So this is going to be like part two of this, of that series. Some of the One of the most common mistakes I see students make all the time is the idea that a plus b, so whenever we do, for example, um, whenever they tell us, let's say a plus b squared is equal to a squared plus b squared, right? So, of course, this is one of the most common ones that I see students make constantly. And we have to understand the difference between these two. So, basically, if I, for example, say, and let's do 2 plus 3 quantity squared, this is going to be, and then if I literally plug it in like this, I'm going to say this is 2 squared plus 3 squared, right? And we'll actually see if that's true or not. I mean, honestly, it's, it's not. The students make this mistake all the time, and I think it's because they think that the 2 distributes in. It doesn't. Not when there's addition going on inside the parentheses. So basically, we know that 2 plus 3 is 5, and 5 squared is 25. But if I square this one, I get 4, and if I square the 3, I get a 9. But 4 plus 9 is 13. 25 does not equal 13, so this can't be true, right? We can't say that. So it's so important to understand the difference, and I think that students make this mistake because they see that, it's true when you're multiplying these two expressions like a and b. We would always say, well, this is just a squared times b squared, right? But it doesn't go for when you're doing addition or subtraction. It's so important to remember that, guys, because it really, I mean, obviously this is a very common algebra mistake that people make, and I can't stress it enough that, especially when you get to calculus and all those things, right? We can see how, vital it is to actually understand the difference between this and, this and this. So really, really try not to make that mistake, guys. So that's the first one. So another mistake that I want to go over is the idea that people always say, and this is yet another one that I've seen students make so much. This mistake is very important to understand the difference. It's basically the idea that if I have a function f of x equals x squared, let's say, and I ask the student to say, well, I want you to evaluate the following. I say f of x, or let's do f of a. Let's do f of a plus h, right? The one thing students do with this is that they think that because there's because in math we say usually when we're talking about a number a times b, we say this is ab. But this is not multiplication, guys. We're not multiplying here. This is a function. There's a difference when you have a function, you're plugging in something. This something that is inside this parentheses here is called an input. We're plugging that in for the function. So our function is x squared, right? We know it's x squared, and we're plugging this in to this, and we're squaring the whole thing. So really, this means the quantity a plus h quantity squared, right? There's a big difference, and I've seen students make that mistake all the time. Even when I say, for example, if I have, I don't know, f of x equals 2x, right? And I say, well, I want you to find me f of, I don't know, let's do, hold on, guys. Let's do f of 2 plus h. Right? And let's say these are two things. And students make this mistake where they think that we're going to do f of 2 plus f of h. No. This is not what it is, guys. When you see an f like this, or like it tells you that it's a function, and it gives you something like this, it literally means you have to multiply this whole thing to this right here, to the input. We have to understand the difference between input and output, and how function, like the definition of functions, to really, really remember how to do this. So yeah. So this is yet another mistake that I see students make all the time. They would distribute where they shouldn't. So kind of similar to this, students would think, for example, if I have 2 times the absolute value of x minus 3 equals 5, that all of a sudden I'm thinking that this stands for, distributive property, and I say the absolute value of 2x minus 6 is equal to 5. No, guys. No. The absolute value symbol is specifically there to enclose, like, think of it as like, to trap whatever's inside that absolute value. So if I have the 2 times the absolute value of x minus 3, I'm really saying that, and I'm having this equal to 5, right? Let's actually do 4 in this case, because I don't want to do 5. But the idea is that the way that you would do it is you would divide by 2, and then you get the absolute value of x minus 3 equals 2. And then from here, this is yet another mistake. Number 4 is the idea that students forget that to make equation inside absolute value equal to positive and negative number. What I mean by that is they forget. So for example, if I have the absolute value of x minus 3 is equal to 2, they always forget that this cannot be changed. A lot of the time, students make this mistake in where they believe that I can say x minus 3 equals 2 or x plus 3 equals 2. But this in here cannot be changed. Do not change what's inside the absolute value. You always make it equal to the positive and negative number. So this is not the correct method. Obviously, it's not. The correct method would be the absolute value of x minus 3 is equal to 2. And so I would then say x minus 3 equals 2, or x minus 3 equals negative 2. We have to remember, guys, that if I have the absolute value of x minus b is equal to a, then x minus b equals a, or x minus b equals negative a. So we have to understand, guys, and this is a mistake that students make all the time. Number 5, I'm gonna keep going here. So another mistake that also involves absolute value is that students forget, for example, the absolute value of x minus 3, and let's do is greater than 2. Students forget all the time that basically they either say this, and this is the wrong way to do it, so this is going to be the wrong method. So we have, and I'm going to kind of do a little line here. So the wrong method would be that I would say the x minus 3 is greater than 2, or x minus 3 is less than 2. That's one of the wrong methods. And then, they would go ahead and solve for, x, and x is greater than 5, or, and then add 3 here. X is less than 5. But then again, I thought x was greater than 5, so that's not correct, right? Another thing they do is that they think that, oh, because I have, and this is going to be wrong method number 2. Wrong method. One second, guys. So this is yet another wrong method. They can say that, this is greater than, add 3 here and becomes x greater than 5, and then minus 3 here, and this is x is less than negative 1. But that's not correct, right? There's so many wrong methods with this. Like with this particular problem, when we're doing absolute value inequalities, you have to remember, and the correct method, I'm gonna just point it out because there's so many wrong methods that students make with this one that it's crazy. I mean, we have to remember the rule, and a lot of students find it very confusing, and this is why it's so important to practice it over and over until you get it, because it's very easy to forget this rule. When I have the absolute value of x minus a, right, is greater than some number b, then x minus a is greater than b, or x minus a is less than negative b. So one of them, not only do I change the make the b from either positive or negative, but I also switch the absolute value symbol. So we have to remember that, guys. It takes practice, and it did take me practice as well to understand that very well. And also, when it comes to actually solving, so this is going to be this is going to be mistake number 5. So, I'm sorry, number 6, mistake 6 is that, it's the idea that, dividing by negative in um, in in inequalities. I can't write today. But basically, when I, for example, have negative x minus 2, and I say this is less than 4, and I want to know, basically, how to solve this, and it tells me to solve for x. Now, again, I'm gonna do the wrong method so that you guys are very aware of what method students make when doing these problems, because the idea is we want to see the difference between the wrong and the right. So the wrong method is that students always end up doing, they do add the 2, which is correct. That part I don't have a problem with. But when they divide, let's say by a negative number here, they always forget to switch the inequality. This is going to be x greater than 6. I'm sorry. They always end up saying x less than 6, but then this is not correct, right? This is not correct. It's not correct, because when we do, for example, negative x is less than a, then this means that basically we divide by negative 1. So when dividing, let me actually write that down a little better. By a negative or multiplying by a negative number, always flip the inequality. Okay, this is so important, guys. When you divide by a negative number or multiply by a negative number on one of these, you have to flip the inequality, otherwise it's going to be wrong. I cannot stress that enough, and this is what drives algebra teachers and even calculus teachers crazy, or calculus professors if you're in college. So this is obviously not the correct way. The right way would actually be the following, and I'm gonna do the correct way. Okay, so basically we're gonna have, so let's say negative x minus 2, we know this is less than 4, and so when we end up adding, so we do add, right? That's literally what we did in this part, which was correct. But we have negative x less than 6. Now, if you divide by negative 1, you have to flip it. So this little thing here, this little inequality symbol, flips. It flips around, right? It's going to be x greater than 6. I'm sorry, negative 6. Excuse me. So you have to be careful, guys. It's so important, and I cannot stress that enough. So yeah, that's one of the things that, that's yet another error. Now, this is another mistake that people make in algebra, and this, not only goes for, it goes for both absolute value and, quadratic equations or functions. When I when a lot of students, this is something that a lot of students make that is just completely wrong. Like, basically it's just very wrong. Like, so basically, um, when you're given a vertex and you know that a is equal to 1, right? We know that the vertex form, let's say the student says, oh, the vertex form is obviously going to be a times the quantity x minus h squared plus k, right? And they end up saying that, this is the vertex form. I don't know why I put vertex. They end up saying that, basically a is 1, so they put 1. And then they say, well, x minus h, well, h is already negative, so I can just put x minus 3 because it's already negative, so I don't need to, make it negative, right? And they end up saying this, and they just say, okay, well, the vertex form is going to be y equals the quantity x minus 3 squared plus 2. No. Absolutely not. And this is yet another mistake that students make all the time. And it's very common. All these mistakes I'm listing out, guys, they're very, very common. So we have to be careful. So basically, the vertex is negative 3, 2. And it goes y equals, and of course, it's a. I said a times the quantity x minus h quantity squared plus k, right? And so we would then say, well, this is 1 times x, and then minus, and we said, of course, the vertex is h comma k, right? hk. But we have to see that h is negative, so we're literally gonna put a parentheses and plug in h is equal to negative 3, right? We would then put minus negative 3 parentheses squared plus, and then put our k value. Our k value here was 2, so that would be plus 2, right? And so then we would end up with the quantity, and x minus negative 3 is x plus 3 quantity squared plus 2. This is the correct answer. It is not this. Okay, so we have to be careful, guys. It's very important, and of course, this is another mistake that students make, and a lot of these errors are, I really, really want to make it clear and really persuade you guys, and just, beg you to please make sure you practice your algebra very well, because these mistakes are made in calculus countless times. So yeah. Okay, guys, so I'm gonna go ahead and stop the video here because I don't want to make it too long, but this is considered part 2 of this kind of series that I have seen where, where students make these very common mistakes. So if anybody does have any questions over this, or if you have other, I really hope this gave everybody some insight. And like I said, I'm doing this to kind of, just help students out in terms of avoiding these mistakes. So I will go ahead and end the video here, guys. And so with that being said, thank you so much for watching. And also please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.